We are starting the unit circle. We're going to start just finding trig values on a coordinate plane for any angle and standard position before we get too far into the unit circle. So this isn't necessarily the unit circle, but it's the start to it. So I want you to be able to find all six. Remember, that's your sine, cosine, tangent, cosecant, secant, and cotangent. All right, so we've got this angle theta again. It says find all six trig values. That's sine, cosine, tangent, cosecant, cotangent for an angle in standard position with its coordinates of 5, -12. So first I want you to plot this point. So I've already done it, 5 over 12 down, and I'm going to label it 5 over, and 12 down looks like this. And my purple line there is the hypotenuse, and this triangle is a triangle that's made like a reference angle because you always make it with the x-axis. And this is a mistake that people like to make. They like to plot 5, 12 and then just kind of draw a triangle in there. That's not what's going to happen. Like, the triangle shouldn't be the other way. So here's a mistake. This is what you don't want to do. This. Okay, so this is not the triangle that we're trying to make. We are working only on this one here. That's the reference angle that is with the x-axis and positive. So we're going to be here in quadrant 4. I need a bigger eraser here. And we are going to find all 6 trig values for this angle theta, and we don't need to know the angle theta to make this work. So this is your angle theta in here. It's the one that makes the reference angle. Remember, that word is theta. And the first thing we need to do is find the length of the hypotenuse. So that's purple. The hypotenuse length will always be positive. Okay, so I'll do that work in purple here. So I have a squared plus b squared equals your hypotenuse squared, or your radius. This is, I'll just call it r for radius, I guess. So this is 25 plus, this turns into a positive 144. Make sure we're not making that mistake. Equals, and then I think you get 169. So c squared equals 169. R then equals positive 13. So the hypotenuse, or that radius, always positive. Okay, it's happy. It's always positive. Okay, so we're going to find the 6 trig values. So at this point, you should be able to do this. SOHCAHTOA. So opposite over hypotenuse. So sine of theta, opposite would be -12 over the hypotenuse of 13. Cosine of theta will be adjacent over hypotenuse. And tangent will be opposite over adjacent. And now we're going to find the reciprocal ones and just flip it. So cosecant theta, that negative will stay in the numerator. This should just be secant. Let me erase that. So secant of theta be positive 13/5. And cotangent of theta will be -5/12. So the negative stays with it, but it moves to the top. We don't put that negative in the denominator ever when we write fractions. All right, so here's kind of working differently. I didn't give you the picture this time, and I didn't really give you the point. So it says suppose theta is an angle in standard position with its terminal side on quadrant 3. All right, so I'm already thinking about this. Quadrant 1, 2, 3, and 4. So I know I need to be in quadrant 3 where sine is -4, 5. So I'm going to draw a triangle. This will be my theta in here. It's my reference angle. This will be my right angle. And I know that sine of theta is opposite over hypotenuse. So the question here comes into play, which one is negative, right? Is it the -4 or the -5? Well, the hypotenuse is always positive, so I know that that's positive. And then I also know, if I think about this in terms of what I'm doing, I have should have a negative x and a negative y because I'm going backwards and down. So this will be negative 4 here because that's my opposite. So first I need to find my other value. So I'm going to say a squared plus negative 4 squared equals 5 squared plus 16 equals 25. So a squared equals 9, a equals 3. But going back to what I said, this is a backward, like I'm moving to the left, so this has to be negative 3. When you take the square root, it could be plus or minus. You need to use your knowledge of the coordinate plane, knowing that quadrant 3 moves backwards and then down, or left and then down, to know that that has to be a negative 3. Because now when we come up with all of our trig values, we need to have the right sign for this. So they already gave us this. Cosine of theta should be negative 3 over 5, and then tangent of theta would be negative 3 over negative 4, and I'm sorry, negative 4 over negative 3, but negative over negative is positive, so positive 4/3. When we flip these, cosecant of theta will be negative 5/4, secant of theta is going to be negative 5/3, and cotangent of theta will be 3/4.